We use glass every day. Our phone is a glass, window is a glass, and even some of our lab equipment is also a glass. But did you know that not all glass behave the same under stress? Some can bend slightly, while others crack instantly. In my final year project, I explore how changing the composition of glass can change everything. So, Bismillahirrahmanirrahim. Assalamualaikum and hi. Today, I'm going to presenting my final year project entitled Physical, Structure and Elastic Properties of Bismuth Borotellurite Glass. Before I begin, here is an overview of my presentation. I will start with the introduction, followed by the problem statement, objective, methodology, result, and discussion, and finally, the conclusion. In this research, I focus on Borotellurite glass, which is a binary system made from TeO2 and B2O3. This glass system is known for its high transparency, good thermal stability, and relatively low melting point. To further modify its properties, bismuth oxide Bi2O3 is added to the glass network. Bi2O3, being a heavy metal oxide, increase the density and improve structural properties. More importantly, it is influenced the elastic moduli of the glass, including the longitudinal, shear, bar, and young moduli. Next is the problem statement. There is a lack of recent research on the elastic properties of bismuth borotellurite glass, despite its potential for advanced material application. This study aimed to fill that gap. In the study, there are two objectives that have been set. Achieving this objective will determine whether the study is successful or not. First, to study the physical and structural properties of bismuth borotellurite glass, and second is to investigate the effect of bismuth on the elastic properties of borotellurite glass. Continue with the literature review. I hope you can read by your own because there are many literature review that I have put in this slide. We have for the glass composition, boron oxide, titanium dioxide density, bismuth oxide, bismuth borotellurite glass, Raman spectroscopy, and lastly ultrasonic pulse echo technique. Next part is methodology. In this study, three main experimental techniques were employed to characterize the physical, structure, and elastic properties of borotellurite glass sample. Method include physical, achievement this principle to get the density. Structural, we use the Raman spectroscopy. And lastly, for the elastic, we use the ultrasonic pulse echo technique, which is to get the elastic moduli. Now, we will continue with the result discussion. For the physical properties, we can get the density and molar volume. Next, for the structural properties, we will get the result for Raman spectroscopy. Meanwhile, for the elastic properties, we will get the ultrasonic velocity, which is the longitudinal velocity and shear velocity. From the velocity, we can calculate the elastic moduli, which is longitudinal modulus, shear modulus, bar modulus, and young modulus. And by using the formula and the result we get from the modulus, which is the elastic moduli, we can calculate the Poisson ratio, micro hardness, divide temperature, and also softening temperature. The results are presented in the graph to clearly illustrate the trend and fluctuation in each parameter. So, we can say that based on the result obtained in this study, most of the major parameters show a varying trend with fluctuation rather than a consistent increase or decrease. This behavior can be explained by the dual structural effect occurring with the addition of bismuth to the glass matrix. Firstly, the incorporation of Bi3 plus ion increased the number of non-bridging oxygen NBO, which generally disrupt the glass network and reduce structural connectivity. Secondly, the formation of strong BiO bond promote glass network compaction, enhancing structural rigidity. The competition between these two opposing effects result in the observed variation across most parameters. For conclusion, the density increased from 0 to 30 mol bismuth due to heavier Bi atom, formation of BiO3, BiO6 unit, and NBO. Molar volume increased due to the Bi2O3 substitution and structural expansion. Meanwhile, Raman analysis confirmed Bi3 plus ion incorporation and formation of TeO3, TO4, BO3 and BO4 unit. Next, ultrasonic velocity decreased due to NBO with lower cross-linking and may increase with more rigidity. For the elastic moduli, fluctuate due to the combined effect of increased rigidity at certain Bi2O3 level and reduced cross-link density from non-bridging oxygen formation. For the Poisson ratio, it increased initially network depolymerization, then decreased network recovery via BIO bonds. For the microhardness, it increased with rigidity but dropped at high Bi2O3 due to structural softening. For the debye temperature, it is decreased, indicating weaker lattice vibration and reduced rigidity due to lower packing density and increased MBO. Lastly, for the softening temperature, it is also decreased with Bi2O3 content due to network losing microvoid and easier atomic movement. And for your information, I also put the references that I have been used in this research. And lastly, I would like to say thank you for watching.